All right, so we're slowly working our way up to being able to factor polynomials, right? And so we now know how to do synthetic division, and we now know how to check if something is a factor or not. But unless you're given something and asked to check if it's a factor, the question you might raise is, okay, I have a polynomial, I want to factor it. How do I even begin to go about checking factors? Right? And so one tool that we have is called the rational root theorem. And the rational root theorem allows us to come up with a list of all possible rational solutions, right? So this doesn't include square roots or imaginary roots that may pop up, but it does give us a way to check every rational solution of a polynomial, okay? So it feels a little bit maybe, I don't know what the word I'm looking for is. Let's see here. I don't know. It feels a little voodoo-y if I had to describe it in a word. But what it's going to do is it's going to give us a list of possible roots, which we could then go and start checking, right, and then begin to factor our polynomial. So what the rational root theorem says is I want to take so our constant term, right? Our constant term is just the number term on the back. And then we also want the leading coefficient. So hopefully we're getting pretty good at picking those off, right? Coefficient. And we want to take, let's see here. So in the numerator, we want all the factors of the constant term. And we want to divide that by all the factors of the leading coefficient. Right? Of the leading coefficient. Right? So what does that mean? Let's see what that looks like. Right? So I don't know. Let's look at an example here. Example 1. I've got f of x is equal to 3x cubed minus 20x squared plus 6x plus 36, right? So what I want to do is take all the factors of the constant term. So the constant term is 36. So all the factors of the constant term are, I've got 1 and 36. I've got 2 and 18. I've got 3 and 12. I've got, oh, I'm running out of space. I've got 4 and 9. Nothing with 5, but I can do 6. And then nothing with 7. Can't divide it by 8. Right? So those are all of the factors of the constant term. Right? Then I want to identify the leading coefficient, which is 3. Leading coefficient is 3. Right? So then over all the factors of the leading coefficient. Now, this is where it gets a little wild. We want to pair up every number from the top with every number from the bottom, right? So I'm going to start and I'm going to pair up every single number from the top with 1, right? Well, 1 over, or anything over 1 is just itself. So the first half of my list of factors is going to be 1, and it's a positive or negative version of that. So I've got 1 from the top over 1 from the bottom and a plus or minus. I've got 2 from the top over 1 from the bottom, plus or minus 2, so on and so forth. 3 over 1, 4 over 1, 9 over 1, 12 over 1, 18, 36, and 6, right? All of those over 1, okay? That's the first half. Now I know it feels like a lot of numbers, but also keep in mind we're looking at an infinite number line, and so if we can limit it down to even a smaller subset, then we've got a far better chance, right? So then I want to take every number and pair it up with, pair it up over 3. So now I've got 1 over 3 plus or minus 1 over 3, plus or minus 2 over 3. And then we can get rid of any repeats. So 3 over 3 is just equal to 1, right? So I don't have to rewrite that one. So now I'm at 4 over 3. That is a unique one, so we'll write that one down, 4 over 3. 9 over 3 is just 3, and we already have that, so we don't have to rewrite that one. 12 over 3 is just 4. 18 over 3 is just 6. 36 over 3 is just 12. And then 6 over 3 is just 2. Right, so this right here is my whole list of possible real rational roots, okay, or real rational factors. So like, for example, if my factor was x is equal to 1, then if I were to write that as a factor of a polynomial, that would be x minus 1, right? And so what we can do then is we can start checking every number from this list. And that's why we want to be able to do synthetic division, because I can say, okay, well, my polynomial was what? Oh my goodness. 3x cubed minus 20x squared plus 6x plus 36, right? So if I were to write this as synthetic division, 3, negative 20, 6, 36, and then I'd want to just start ripping through synthetic division and just start testing. So maybe I start with negative 1, right? And I do synthetic division, and if I get a remainder of 0, then that's a factor, right? Maybe it's not a factor, maybe I get 8, right? So then I try positive 1. And so I rip through some synthetic division, and I get some number, and it tells me whether it's a remainder or not. So this is where the rational root theorem combined with synthetic division allows us to start checking factors really quickly and putting it all together. So in a future video, we'll put all of this together and start factoring polynomials. It's a difficult thing, right? It's a lot of maybe it's a little bit tedious, but it is finding the factors and zeros of a polynomial are a very important idea as you progress on in math. So this will be a very useful tool for us, right?